Hi, my name is Alamuta Dessa. Today we will see the last class of antibacterial classes. Please don't forget to subscribe, share, and like my video. If you remember at the beginning of antibacterial compounds, these antibacterial compounds, they are classified either based upon their chemical structure or based upon their mode of action. Therefore, based upon their mode of action, the first class of antibacterial compounds, they are known as folate antagonists or antimetabolites or folic acid antagonists. These compounds, they are sulfa drugs. Also trimethoprim, sulfone, they are the class of compounds that are categorized under folate antagonists or antifolates. The second class of antibacterial that will inhibit the bacteria, they are called bacterial cell wall synthesis inhibitors like beta lactam compounds, penicillins, and cephalosporins. The third class of antibacterial compounds, they are called those that alter the cell membrane or those that interact with plasma membrane. These compounds like polypeptides are the most popular type of drugs that are classified under this class. And the fourth class of compounds, they are called protein synthesis inhibitors, meaning that drugs that will inhibit the synthesis of proteins. These are the fourth class of compounds, and the fifth and the last class of compounds that are classified based upon the mode of action are those that interrupt, those that inhibit bacterial nucleic acid. These are DNA polymerase inhibitors, or that will block the DNA polymerase or RNA polymerase. Such compounds, they are very important compounds for treatment of large number of bacterial infection. These drugs include rifamycin and the quinolones. Quinolones, they are very important compounds that are used for treatment of many bacterial infection. Therefore, let's see the structure-activity relationship of these quinolones and some pharmacological activity of these quinolones. Before that, these quinolones and some other antibacterial compounds, they are very important drugs for treatment of UTI infection, urinary tract infection. This includes quinolones, nitrofurantoins, and sulfonamides are very important compounds for treatment of UTI. Generally, these compounds, quinolones, they are the very important compounds that are used for treatment of UTI. What are quinolones and the quinolines? Quinolones, they are compounds that contain this ring. They are called quinolones. Compounds containing this structure, they are known as quinolone. For example, the structure of ciprofloxacin. Here, in the structure of ciprofloxacin, we have two fused rings. On the two fused rings, one is aromatic, meaning that benzene, the other one is substituted six-membered alkene with heterocycle nitrogen here. Such type of compounds, they are called quinolones. What is the difference between quinolones and the quinolines? Quinolines, they are compounds. This is an example of quinoline. Here, it is quinoline. This is carbon nitrogen is number one. Quinolines, they are antibacterials, antimalarials. They are also important anti-leishmanial drugs nowadays. Therefore, here quinolines, if they are substituted at fourth position with oxygen, they are termed as quinolones. Quinolones nowadays, they are the very important compounds that are used for treatment of bacteria. They are potent antibacterial compounds. Quinolines, such as chloroquine, such as primaquine. Also, we have quinine, quinidine. They have this nucleus, this quinoline nucleus. They are different from quinolone antibacterial compounds. In the case of antimalarial compounds, quinolines, these antimalarial quinolines, they may have alkylamino side chain at 4 position, this is 4 position, or they may have alkyl amino side chain at 8 position here. Additionally, they may have methoxy group at 6 position or halogen at 7 position in the case of anti-malarial quinolines. But antibacterial quinolones, they are compounds that contain the quinoline nucleus, this compound. They have additionally the O carbonyl group at 4 position. Most of them, they have also carboxylic group at 3 position. Structurally, modification produces potent quinoline derivatives like quinolones. Also, these quinolones, they are also classified based upon the substitution. These are fluorine substitute we have, mainly most of them they are quinolone antibacterial compounds. They have chlorine at 6 position. Those that contain this nucleus, they are called fluoroquinolones if there is fluorine at 6 position. This is number 1, number 2, number 3, number 4, number 5, and number 6. They are called fluoroquinolones. These are essential antibacterial compounds. The history of quinolones was started from the discovery of naldexic acid in 1963. This is the first compound that was used for treatment of UTI. This is a structure of naldexic acid. This is a structure of naldexic acid. This is a structure of naldexic acid. The first compound that was identified is naphthahydrine. This, by modifying the structure of naphthahydrine, they developed the compound known as naldexic acid. It was developed from naphthahydrine. It has substitution at 7 position. Here, this is a 7 position. 7 methylated group here. It is naldexic acid derivative. Also at 1 position there is ethyl group. At 3 position there is a carboxylic group. Also there is O at 4 position. This is the first synthetic antibacterial agent, naldexic acid. Also another newer antibacterial compounds, they were identified that contain additional nitrogen at 2 position. These are called quinolines. This is a structure of quinoline. There is another additional nitrogen that will increase the penetration power of that molecule. Example of this class of compound is cianoxacin. There is substitution here, additional substitution here. In the case of cianoxacin here, also another heterocyclic substitution here. These are the compounds that are used for treatment of UTI. They are called quinolones because they have C double bond O or ketone at 4 position. They are called quinolones. From this compound, later by modifying and using the structure-activity relationship by drug development strategy, molecular manipulation, and molecular modification, these fluoroquinolones, they were identified. Fluoroquinolones are compounds that contain fluorine at 6 position. They were identified. This is a structure of fluoroquinolones. They were identified. When we come to the structure-activity relationship of fluoroquinolones, they have this general structure. This is a general structure for fluoroquinolones when they have fluorine at 6 position. Therefore, for such compounds, a very important thing is that number 1, the pharmacophoric group. Pharmacophoric means the group which is responsible for pharmacological activity or biological activity. It is very important. Mainly, this part is essential in the structure of fluoroquinolone. This is number 1, crucial for activity. The 2,3 double bond, the carboxylic group, also the carbonyl group at 4 position, they are important. In fact, also this ring is substitution on this ring, they are very important. But very essential, crucial is this ring is pharmacophoric group, the group which is number 1 for activity. This is essential. The reduction of this double bond also leads to elimination of activity. This double bond is important for activity. Antibacterial potency, it depends upon the double bond, because this double bond is the part of the pharmacophoric group. Therefore, these compounds, they have fluorine at 6 position. The fluorine at 6 position is very important for increasing lipid solubility. It will determine lipophilicity of many fluoroquinolones. This lipophilicity also enhances the penetration power of the drug into the cell. Very important. Therefore, the penetration power will depend upon fluorine at 6 position. Also, these compounds, they have piperazino group at 7 position. Here, many of the fluoroquinolones, they have piperazino group at 7 position. Piperazino group means it's 6-membered ring. 6-membered ring. Let me draw the structure of piperazine group. This is piperazine group, 6-membered ring that contain 2 nitrogen at 1,4 position. This is called piperazino group. Therefore, piperazino group or piperazine group at 7 position is very important for spectra. Compounds that contain piperazino group at 7 position, they are potent and broad spectrum. This will increase the range of activity. But the presence of the piperazino group at 7 position, it has CNS side effect because it is highly affinity for the GABA receptors, which can contribute to the CNS side effect. Therefore, to decrease this side effect that is associated with the piperazino group, which is important for spectrum, the introduction of alkyl group on piperazino group or any one position. Here, introduction of bulky group or alkyl group here, mainly cyclopropyl group, bulky group on the nitrogen 1 position, they will decrease this unwanted side effect. The piperazine side effect can be decreased by incorporation of alkyl group either at 1 position or on the piperazino group. Here we can see this is the structure of quinolone. Look here. Here we have piperazino group at 6 position. This is a piperazino group at 6 position. Therefore, it has side effect, CNS side effect. Therefore, to decrease that side effect, incorporation of alkyl group here or incorporation of alkyl group on the piperazine will decrease those unwanted side effects, because the presence of the piperazino group at 7 position is important for activity. Replacement of carbon 8 by nitrogen, this will increase bioavailability. Here, look here, in this general structure, this is the 8th position. This X, it may be carbon or nitrogen. That is possible. Generally, the conversion of carbon into nitrogen increases bioavailability by increasing its transport through membrane. It is very important for bioavailability. Introduction of additional fluorine at 8th position for carbon containing compounds. For example, here, introduction of another additional fluorine at 8th position. This 8th position, 1, 2, 3, 4, 5, 6, 7, 8th position. If it is carbon, fluorine substitution is possible. This will increase the duration of action. This will increase half-life. This will increase absorption through memory. Therefore, additional fluorine at 8th position is essential for activity. And finally, addition of fluorine at 8th position. Here, addition of fluorine at 8th position in this structure. This is a general structure. Let me go to the general structure. In this structure, addition of fluorine here, introduction of amino group here, also introduction of cyclopropyl group at N1 position or R1 will increase potency. Therefore, potency of fluoroquinolones depends upon three very important things: the presence of cyclopropyl group at N1 or R1 position, the presence of fluorine at 8th position or R8 position, the presence of amino group at 5 position. They are very important for activity. Also, the presence of amino group at 5 position is important to reduce phototoxicity, essential for fluoroquinolones. These are the structure-activity relationship of fluoroquinolones. Therefore, let's see some examples and exercises. These are examples of common type of fluoroquinolones. We have the most popular type of drug that is commonly used for treatment of many bacterial infection is ciprofloxacin. Look, in the ciprofloxacin, we have cyclopropyl group at N1 position, fluorine at 6 position. Also, we have piperazine group at 7 position. We have lomifloxacin, pefloxacin, gatifloxacin, sparfloxacin. They are some of the examples of the fluoroquinolones. Let's do these exercises. The first question is said that identify the drug with greater half-life and increased absorption. Therefore, to increase absorption and half-life, number one is the presence of fluorine at 8th position. Meaning that both fluorines at 6th position and 8th position, they are important for absorption and half-life. Fluorine at both places. In fact, most of these fluoroquinolones, they have fluorine at 6th position. That's why they are called fluoroquinolone. Addition of another fluorine at 8th position will increase half-life, will increase absorption. Let's see. Here, I don't have here. There is no fluorine group here. In the case of the first compound, structure 1, there is no fluorine here at 8th position. We have fluorine at 6th position. Therefore, only 6th position is important for lipid solubility. That can increase penetration, but not half-life and absorption. Look here, no fluorine at 8th position. Look here, there is no fluorine. Here, look fluorine. Also, it has additional fluorine. Therefore, compound 5 has, and compound 4, both of compound 5 and the compound 4, they have fluorine at 8th position. Therefore, compound 4 and compound 5, they have increased absorption and they have increased half-life. The second question, which one is the most potent antibacterial agent? Therefore, for potency, there are 3 very important factors. Number 1, the presence of fluorine at 8th position. Number 2, amino group at 5 position. Number 3, cyclopropyl group at 1 position. Therefore, let's search drugs that contain these 3. Therefore, look, in the case of the first compound, we have cyclopropyl group here, no amino group, no fluorine. Cyclopropyl group, there is an amino group, but there is no fluorine here. This is potent than this one. This is more potent than this one. And the third compound, we have cyclohexyl group, we have no amino group, we have no 8 fluoro group. And this compound, compound 5, we have cyclohexyl group, cyclopropyl group, we have amino group, we have fluorine. Therefore, this compound is the most potent according to the structure-activity relationship. This compound is more potent than the other 5 compounds. Then, which one of this drug given has broad spectrum antibacterial? Therefore, for a spectrum, the presence of the piperazine group is essential. All these compounds, they have piperazine group except structure 3. Look, we have piperazine group, we have piperazine group, we have piperazine group. Also here we have piperazine group. But in compound 3, there is no piperazine group here. Piperazine, it is not piperazine group. Therefore, it's not broad. The others, they are broad. They have increased activity. They have better spectrum than the others. And the other question, which of these drugs has narrow spectrum? Narrow spectrum is compound 3. When it is compound, because there is no piperazine group. And the last question, which of these compounds has reduced phototoxicity? Therefore, for phototoxicity reduction or reduced phototoxicity, the presence of amino group at C5 position is important. Look the compounds that contain amino group at C5 position. Compound 5 and compound 2, they have amino group. These two compounds, they have reduced phototoxicity. This is all about the structure-activity relationship of quinolones that are very important for treatment of many bacterial infection. Thank you so much. Please don't forget to subscribe, share, and like my videos.